Okay, we've talked about confidence intervals in a couple of different lectures, and I want to point out something that I'm not sure if you noticed or not, but those confidence intervals, and also the hypothesis tests that we've done, by the way, we're always asking about the mean or the average of something. Like, what is the average age that smokers begin smoking? Something like that. Okay. Today we're going to do confidence intervals for something different. Confidence intervals for a proportion. Okay? Like, for instance, before a political election, you hear polls all the time saying this percentage of people are going to vote for candidate A. Okay? A percentage is a proportion. That means how many people out of 100 are going to vote for that candidate. Okay, so I'm going to show you how they do those political polls. Okay, and it's very similar to the confidence intervals that you do for means, but it's just a slightly different formula. So here's what you need to write down. I am going to label this as information needed for a confidence interval for a proportion. All right, what you need is, you need your sample size. We'll call that N like we usually do. Okay. You need the number of successes from the sample. We'll call that lowercase x. When we say successes, what we mean is something like this. If the poll is asking the question, are you going to vote for candidate A? Then the number of successes means the number of people who are going to vote for candidate A. You can think of it like this. Think of it as though the poll is asking you a yes or no question, then the number of successes is the number of yeses. Okay? Now, it's possible that the way the poll is worded, it might not be worded as a yes or no question. But you can certainly, in your own mind, you can say, all right, I'm going to take that question and I'm going to rephrase it for myself as a yes or no question. Okay, you can do that yourself, even if the poll's not worded that way. And then you can say, all right, based upon what they told me, this is how many yeses we would have. And that's the number of successes. That's what we're calling lowercase x. Okay? All right, now you need the proportion of successes from the sample. Okay, we will call that P with a little, what do you call that, apostrophe? In math, we call that a prime, so we say P prime, okay? Some books instead put this little symbol over it, and you call that P hat. but our book uses the prime symbol, so I'm going to use that. And that is simply the number of successes divided by the size of the sample. Okay, now, depending upon the way a question is worded, they might tell you this number in the question, and in that case, you would not need to know x. The thing that we need to know is we need to know p prime. Okay, you use x and n to find p prime, but if they tell you p prime directly, then there's no need for you to know x. We will still need n. All right. You need to know what confidence level you want to use. I am told that political polls normally use a 95% confidence level. Okay, and we're going to call that alpha. And the last thing you need is the z-score for the probability alpha over 2. Which we've done many times, but if that sounds like something that you don't know what that means, then you'll see in just a minute. Okay, now here's the formula for the confidence interval. Okay, so the confidence interval for the true population proportion which we call P, is the true population proportion, and P prime is the sample proportion. Okay, and here's the formula for the confidence interval. We say that P will be in this range from P prime minus the z-score for alpha over 2 times the square root of P prime times 1 minus P prime divided by n. Okay, and the upper end of the confidence interval is P prime plus the z-score for alpha over 2 times the square root of P prime times 1 minus P prime over n. And this number right here that is your margin of error. I'm going to write MOE, margin of error. Okay? That's technically all there is to it. Let's practice a few times. Okay, we're going to do this question. All right. Before we start it, let me correct one mistake I said earlier. Your confidence level, I said we're going to call that alpha. Let me fix that. Alpha is not the confidence level. Alpha is 1 minus the confidence level. Okay? So let me do this. Let me write alpha and then I'll write alpha equals 1 minus your confidence level. Okay, that's the way it should be. All right, let's do this question here. Suppose a market research firm is hired to estimate the percentage of adults living in a large city who have cell phones. 500 randomly selected adult residents in the city are surveyed. So N is 500. To determine whether they have cell phones. Of the 500 people sampled, 441 responded yes. That's the number of successes. 421. Using a 95% confidence level, so our confidence level is 0.95, okay? Compute a confidence interval estimate for the true proportion of adult residents of the city who have cell phones. Now, these are the only 3 numbers we need. The size of the sample, the number of successes, and what confidence level we want. That's the only 3 numbers we need. Okay? We're going to use those to calculate 3 more things. Okay? We're first going to calculate our estimate. This is not the estimate. This is the actual proportion from the sample. So that's X divided by N. Okay? And that comes out to be 0.842. Okay, then we need to calculate alpha, which is really easy. That's 0.05. And then we look up the z-score for alpha over 2. And let me remind you, let me write down what I got and then I'll remind you how I find it. Okay? So I got 1.95996. Okay? Now, let me remind you of how I found that z-score. I'll go over 2 ways. One is to use the table in the back of the book. This is not the way I suggest because I think it's more difficult, but you can do it this way. The table in the back of the book. Let me just remind you. Has to be used like this. Okay, what's alpha over 2? It's 0.025, right? 0.025. Okay, now, this is why I don't like using the table in the back of the book. we know that this half of the area is 0.5. So if we want this whole area right here to be 0.975, here, let me explain that. Here, let's erase this. Let's start with this. Alpha over 2 is 0.025. So that means we want this area right here to be 0.025. We already know that this area over here is 0.5. So what would this be right there? That's the question. Okay. That would be 0.475, right? That's the number we would look up in the table. And you're probably not going to find it in the table. That's another problem. You're probably not going to find 0.475. So you have to find the number in the table that is as close as you can to 0.475. Oh, actually here, we get lucky. That number is, in fact, in the table. And then so you look at the left-hand margin and the top of the table to write down the corresponding z-score. And I see from the table that it's 1.96. Okay? Now, I think that's not the best way to do this problem. I think that's more work than you need to do, because you have to calculate this number right here. Okay, so my suggestion is to just forget about the table in the back of the book and instead open up Excel or something similar to Excel. Okay, and just type in the command. On Excel, the command is equals norm dot s dot inv, and then you just put here in parentheses 1 minus alpha over 2, which is 0.975. Okay, that's 1 minus alpha over 2. And it will immediately tell you your z-score. And not only that, it gives you a more accurate value. Remember I said the table in the back of the book says 1.96. The computer will give you a more accurate value. We get 1.95996. So that's what I highly suggest. It's way easier than using the table in the back. It is way faster than using the table in the back. And you get a way more accurate number. So 3 reasons why it's so much easier to just use a computer to find your z-score. But if you don't have a computer, you can use the table in the back. All right, picking back up. Let's see. So let's just make sure where we were. We found 3 numbers that we needed from the problem. We use those numbers to calculate first the sample proportion. We write down alpha. I used Excel to find the z-score. Okay, and then I can calculate my margin of error. Which is what? It's our z-score I'll show you again the formula. This is where I'm getting it from, right there. Do you see it? It's the z-score times the square root of the sample proportion times 1 minus the sample proportion divided by the sample size. Pretty straightforward. Okay, you just put that into a calculator, and what I'm getting back is 0.03197. 0.03197. That's our margin of error. And our confidence interval is P prime plus or minus the margin of error. P prime minus the margin of error to P prime plus the margin of error. Okay, and that comes out to be 0.81003 to 0.87397. So what can we say? We can say that with 95% confidence, the percentage of people in the population that own cell phones is in this range. Roughly 81 to 87%. Okay? So I know there's a lot of words being thrown around here, but the actual work that you have to do is very little. Okay, let's do another practice. The Dundee Dog Training School has a larger than average proportion of clients who compete in competitive professional events. A confidence interval for the population proportion of dogs that compete in professional events from 150 different training schools is constructed. Well, they're telling us right there that the sample size is 150, so let's write that down. Okay. All right. The lower limit is determined to be 0.08, and the upper limit is determined to be 0.16. So that means they're giving us a confidence interval. They're not asking us to construct a confidence interval. They are telling us what the confidence interval is. It goes from 0.08 to 0.16. It says determine the level of confidence that was used. What was the level of confidence? Can we really figure that out with such a little amount of information? If they give me a confidence interval and they tell me what the sample size was, can I really find the level of confidence just from that? Well, I think we can. Okay, let me walk you through it. First, let's write down what the margin of error is for that confidence interval. Okay, let me remind you of something. This is P prime minus the margin of error, and this number is P prime plus the margin of error. So then the margin of error is half of the distance between those two numbers, right? In other words, 0.16 minus 0.08 divided by 2, that's the margin of error. Okay, and that comes out to be 0.04. All right, that's the first step. Okay, now, what's the formula for margin of error? Let me remind you that the formula for margin of error is the z-score for alpha over 2 times the square root of p prime times 1 minus p prime over n. That's the formula for the margin of error, and we figured out that that formula should give us 0.04. Okay, I need to know one more number, which is I need to know what p prime is. So once again, let's look up here. The confidence interval is p prime plus or minus the margin of error. So that means that p prime is right in the middle of the confidence interval. Okay, how do I find the middle of two numbers? Instead of doing 0.16 minus 0.8 over 2, I do 0.16 plus 0.08 over 2. That's the average of those two numbers. That's going to tell me what is right in the middle of the confidence interval. Okay, and that's going to be 0.12. So that's my p prime. Okay, so here's what we're going to do. I'm going to take this formula right here, and I'm going to copy that down. And I'm going to write an equation, and I'm going to say that equals 0.04. And then we're going to use some algebra. Okay? All right, so let's write this down. The z-score times alpha, for the number alpha over 2, okay, times p prime times 1 minus p prime over n. That equals the margin of error. And let's fill in the numbers that we know. Okay, we know the margin of error is 0.04. We know p prime is 0.12. And we know n is, I was going to say 500, but it's 150. Okay, let's just use some algebra here to find our z-score. Okay, so we have the z-score times, let's calculate this number right here. That's just a calculator problem. Okay, we just put that into our calculator. 0.12 times 1 minus 0.12. Divide that by 150 and calculate the square root. That is whoops, wrong color. 0.02653. Okay, divide both sides by that number. This is just algebra. We get the z-score equals 0.04 divided by 0.02653. Okay, what does that come out to equal? That comes out to be 1.5 0.756. Okay, we either look up that z-score in the table or we'll put it into Excel. Let me just go over both of those with you again one more time. If you look it up in the table in the back of the book, here's what you would be doing. You would be looking up 1.50756, except there would be a problem. The table in the back of the book only lists the z-scores to 2 decimal places. So you can't look up 1.50756. You would have to round that off to 1.51. Okay, here's what the table would tell you. It would tell you the number 0.4345, and that is this area right here, 0.4345. And what does that tell us? That tells us that in this region right here, we have how much area? That region represents our confidence interval. Okay, it represents the probability of landing inside the confidence interval. And how much area is there right there? That's 0.869. So what's that tell us? It tells us the confidence level is 86.9%, which is actually not very high. You are familiar with seeing numbers like 95%, 98%. Sometimes you'll see 99.9% if somebody wants to be super careful. If somebody wants to be not very careful, then sometimes you'll see a confidence level as low as 90. Here we have a confidence level that's under 87. That is extremely low confidence level. Now remember that to use the table in the back of the book, I had to round off this number to 1.51. So let me show you that if I did not do that rounding off and I typed this number into Excel, then I will get a more exact answer, more precise, and it means the confidence level is actually even lower than what we found if you're more precise, because here's what I do. In Excel, I type in equals norm dot s dot dist 1.50756 comma true, and the number it gives me back is 0.93417. Very different number, but you have to remember that when you do this in Excel, it's giving you a different area than the Z table in the book gives you. When you do this in Excel, it's giving you this whole entire area there. That is 0.93417. Now, if we break off this 0.5 that we know is over here, then that leaves here 0.43417. So if I then reflect that to the left-hand side, Because remember, our confidence interval goes from there. The confidence interval does not go all the way to the left-hand side of the picture. It stops here. So this is also 0.43417. And so our confidence level is 0.86834. So 86.834%. It's actually a little bit less than the 86.9 I used. It's a little bit less than the 86.9 I got when I used the table in the book. Okay, all right, let's move on and do one more and then we'll finish for the day. Suppose a mobile phone company wants to determine the current percentage of customers, 50 plus, who use text messaging on their cell phones. How many customers should the company survey in order to be 90% confident that the estimated sample proportion is within 3 percentage points of the true population proportion? Okay, what are they giving us here? It's saying that we want 90% confidence level and okay, that was right there. That's obvious. But look here. What's that mean? Within 3 percentage points. That means, and we want a 3% margin of error. That's what we want. The question is, how big does n need to be? Okay, let's figure that out. Okay, here's how we do this problem. We know that the margin of error, I'm going to write down the formula for the margin of error. Okay, so remember, I'm going to scroll up so you can see it. It's right here. Hold on a minute. Okay, there's the margin of error. You see it highlighted in yellow near the top there? The margin of error is z of alpha over 2 times the square root of p prime times 1 minus p prime times n. So let's write that down. Margin of error equals the z-score for alpha over 2 times the square root of p prime times 1 minus p prime over n. Okay, let's solve that for n. Okay, how are we going to do that? Well, you just use algebra. Let's multiply both sides. Here, let's do this. Let's square both sides. So that we can get rid of the square root. So that gives us the margin of error squared equals the z-score for alpha over 2. Let me ask you, what's alpha over 2? The confidence level is 90%. So alpha is 10%. So alpha over 2 is 5%. Okay, squared, because we squared both sides, times p prime times 1 minus p prime. The square root has disappeared because of squaring both sides. And that is over n. Okay. Multiply both sides by n. We get the margin of error squared times n equals the z-score for 0.05 squared times p prime times 1 minus p prime. What do I do next? Divide both sides by the margin of error squared. And we get n equals z-score squared times p prime, the proportion from the sample, which I'll point out that they did not tell us. That's going to be a little bit of a problem. Times 1 minus the proportion from the sample, divided by the margin of error squared. Now, let's put these numbers in. We look up the z-score for 0.05. Okay, we've done that several times now, so you should know how to do that. I looked it up and I see 1.64485. So let's put that 1.6. Hold on, my pen is not working. 1 second here. 1.64485 squared. Okay, that's the z-score squared. On the bottom, I can plug in the margin of error. They gave us that. It's 3%. So on the bottom, I have 3% squared. Now, here's the part that's a little bit tricky. Right here. The sample proportion times 1 minus the sample proportion. They didn't tell us the sample proportion. So here's what we're going to do. We are going to use the worst case scenario. I want you to notice that the bigger p prime gets, the smaller 1 minus p prime gets. The smaller p prime gets, the bigger 1 minus p prime gets. The product, p prime times 1 minus p prime, will be as big as possible exactly when p prime equals a half. So we're going to use that because it is the worst case scenario. So I put in a half for p prime. My computer is heating up and that's why it's not working very well, but there we go. Okay, there we go. Put in a half for p prime. Then 1 minus p prime will also be a half. And there you go. You put that number in your calculator. Okay, and let's see what we get. 1.64485, and then that is squared. And then that's times a half. And then times a half once again. And then we divide that by 0.03 squared. and I get 751 point, and then there's a little bit more after that. I'll just write down 4 decimal places. 5, 3, 6, 5. So, in order to have a confidence level of 90%, and in order for the margin of error to be 3% or less, okay, margin of error to not exceed 3%, then n has to be at least 751 people. 0.53, I'll say. Sorry, let me not forget that. N needs to be at least 751.5365 people. Okay, I cannot find 0.5365 of a person. So, if I need at least 751.5365 people, and people only come in whole numbers, then that means I must sample at least 752 people. I'm writing slow because my pen is not working well. But this is the end of the problem, and it's going to be the end of the lecture, so we're almost done. Okay, and that's the answer to our question. Okay, come to my office hours if you need help. Have a good afternoon.